Got it. Oh, it's 111. Shut this down. All right, so Zoom has been kind of acting up a little bit, so we're gonna just do the best that we can. If you're not seeing my screen, you have to bring it to my attention. It has totally been on the fritz for the past couple of a week or so. So we're just gonna do the best that we can. Again, and me let me pull it up on my end so I can see it. This one. There it is. So that way I can at least monitor. Suppress you. Okay. All right, so far it looks like it's okay. Let me see. Now, as far as announcements go, welcome, gentlemen. We are in the home stretch, right? Like, I think we have, let me pull up a calendar really quickly. I think we have, let me see. So today is the 14th. Next week is Thanksgiving. So we have this week. Next week, I think we only have Monday. That usually that Wednesday we don't meet. And then the following week we have a full week, that Monday and Wednesday, right? So we have about 2.5 weeks remaining. So my thought process was, well, let's take this time to review for the final. So I was thinking that we can focus on one exam per week, right? So we've had a total of 3 exams. Let me see so I was thinking that for this week, we can just do things that pertain to exam 1, right? Going through, you can ask if you have questions about other things, if you need help with anything, like if you're working on an exam or trying to improve a grade, you could actually be working on it right now. Say, hey, can we work on this question and we can do it together? Go ahead.
When is the exam available?
Okay, that's coming. Let me kind of get through this. I'm going to answer that question. All right. So yeah, an exam per week. Let me see. So exam 1 this week, even though we meet only on Monday next week, but we can take that time to review for exam 2. We take our Thanksgiving holiday, and then the 28th and the 30th, we can focus on exam 3. So then that Thursday and Friday, so the 30th, I'm under the impression that November 30th is the last day of class. So then December 1st and 2nd should be the reading period, which means you shouldn't really be meeting in any of your courses. We don't meet on Thursdays and Fridays, but again, that's supposed to be the reading period. So then I think I scheduled your final exam to become available that Sunday, December 4th at 11:11 a.m. I usually make them available at 11:11 the Sunday before that week, right? And then your final should be available all the way up until that hard deadline of Friday, December 9th at 11:59 p.m. Right? So what that means is that not only will your final exam be due, but everything on Pearson is going to be due, right? So we can't, the goal or the idea is that when you submit your final exam, that should be the last thing. You shouldn't have anything lingering. If you're going back and working on old assignments to improve your overall grade, may I encourage you to prioritize your exams, right? Even if I would encourage you to you can work on it right now while we work on this other things. Like if you get stuck on a question or something of that nature, bring it to my attention during class and we can work on it together. But yeah, you want to definitely prioritize your old exams as they count for near 80% of your overall grade, right? And then the last thing you want to prioritize is the old homework, where that's going to be a whole bunch of work for very little points, right? So you wouldn't really see your grade move working on the homework. I don't want you to stress about trying to finish all that homework. Do the best you can with the homework, but if you don't get anything else in order on Pearson, you definitely want to get your exams in order. Are there any other questions before we just start reviewing? So I was thinking today, let's go through as many homework sections pertaining to exam 1, maybe 10 minutes per section. And then on Wednesday, we'll see how many questions on exam 1 can we get through, right? So just to kind of change it up and to dust some cobwebs off. So let's hop over here to Pearson. You see exam 1 there, and let's just take about 10 minutes. If it's 20, 30, and 20 is 50, right? So 10 minutes a section. So let's take 10 minutes and, just go through section 1.1, we can improve. Let's just review and practice. It doesn't really matter. So maybe I'll work backwards. Since we answered questions 1 through 10 together, let's just start with question 11. Let's at least try to touch on things that we may not have discussed together, right? So to try to be as complete as possible. Let's see what's going on here. For this function, answer parts A through D below. Determine algebraically whether the given function is 1-to-1, right? Okay, that's a great question, right? So 1-to-1, the next 4 statements are equivalent and can be used interchangeably. Whenever we say a function is 1-to-1, that's the same as saying the function has an inverse. That's the same as saying the graph passes the horizontal line test. That's the same as saying every y corresponds to exactly 1x. If I need to write that out, just let me know. But let me say it one more time. So the following 4 statements are equivalent. A function being 1-to-1 is the same as a function having an inverse, is the same as a function passes the horizontal line test, is the same as every y corresponds to exactly 1x, right? So that was one of the first concepts that we talked about. This whole experience is a thing about concepts, right? Hey Siri, set a timer for 8 minutes.
8 minutes, starting now.
I will totally get lost with the time, so I got to use timers for stuff like this. Okay, so algebraically, let's see how to determine algebraically if this is 1-to-1. Basically, to do it algebraically, if you set 2 different y values equal to each other, and then you got to show that in order for it to be 1-to-1, when you set 2 different y values equal to each other, then the x values have to be equal. If you start with 2 different y values that are equal, but you finish with 2 x values that are not equal, then that means the function is not 1-to-1, right? So let's write that out as far as what do we mean. So for this function, show algebraically, right? We got f of x equals 12 minus 3x, all right? So let's take some notes. F of x, hang on. F of x equals 12 minus 3x. Now this is question number 11. This comes from section 1.7. And this is question 35 from the back of this section. All right, there is a lag. I'm trying to think of how to accommodate that. Okay, but to show a function is 1-to-1, and let's say to show that it's 1-to-1, basically we need to show that when we start with f of a equal to f of b, then we finish with a equals b. All right, that's what we need to show. Okay. So let's start with f of a equal to f of b, right? So then that's going to be what? 12 minus 3b equals 12 minus 3a, right? Notice we can subtract 12 on both sides, all right? They're going to cancel. So then we're going to have, I'm just keeping my equal sign lined up. We're going to have negative 3a equals negative 3b, right? We can divide both sides by negative 3, all right? A equals b, boom, all right? So we started with f of a equals f of b. We finished with a equals b. So that means that this function is 1-to-1. It's like a uniqueness or something like that. But that's how we show a function is 1-to-1 algebraically, right? That's what they wanted to see there. So is this function 1-to-1? We're going to say yes. And that was it. Oh, wait a minute. I don't think we did it right. We're going to say yes. Is there enter? Okay, let me try something. Let me close this out. Let me cancel. Let me click on this. Let's go back again. Go back. Go back. Let me close this out. Let me view. Okay. And then we're working on this one. Inverse functions. Let's improve the score so that way we can get some feedback. Continue. Okay. And this is the one that we were working on. And then, come on. I know we're running a long time. This is close enough. I think it's going to be the same kind of deal. So I'm just going to hit yes and final check. That's what I was looking for, right? Okay. So then part B, if the function is 1-to-1, find the inverse. Okay, excellent. Oh, they got me. Okay, so now to find the inverse, right? So basically, and I'll just do a quick. Let me get the copy of the original first. 4 minus 2x. Okay. So if we're starting, starting with f. Oh my goodness. Hang on, because this thing is like lagging. Let me see if I reboot this, if that fixes it. Right here. Come on, you can do it. I believe in you. Did you crash? Yeah, that was my hesitation. Okay, you guys probably, oh, no, it's there. Okay. And let me check one. It says 4 minus 2x, right? So we're starting with, there we go, that's better. 4 minus 2x, all right? So basically, to find the inverse of a function, now that we verified that it has an inverse, to find the inverse, we replace f of x with y, we switch x and y, and then we solve for y, right? So here, first we're going to replace f of x with y. Okay. Next, we're going to switch x and y. So wherever there's an x, you write y. Wherever there's a y, you write x. And that'll give us x equals 4 minus 2y. Okay. And I'll make a note that says to find the inverse. To find the inverse. I mean, this stuff just goes, like it goes deep, you know. It's just a lot of information. Hopefully we can like dust off the cobwebs and like position everyone for success, right? Let's keep going. So then from here, again, we replaced f of x with y, we switched the x and the y, now we solve for y, all right? So we can like add the 4 to both sides. That's gonna give us negative 2y equals x plus 4. Divide both sides by negative 2, y equals negative 1/2 x minus 2. And then you replace y with f inverse. And again, if anything is not clear, feel free to unmute yourself. So what this is saying is like, if we start with an x and we pass it through f, we're going to get an output. If we take that output and pass it through this inverse, it's going to take us back to the original x, right? So we got a negative 1/2 x minus 2. Let me think about that. Let's see. All right, that's the timer. Let's try to finish this question out. Okay. So if we see, I think I made a mistake. I should have subtracted. I knew something didn't look right. Okay. Doing too much at once, right? I should have subtracted 4. I think I added 4, right? So this is supposed to be a minus. Let me do that in red. This should have been a minus 4. That would have made this a plus 2 and a plus 2. Let's see if that fixes it. You subtract a 4 when you divide by a negative. Still feel like something is off. Maybe it's okay. If we add that, let's just go with it. Let me check it one more time. Okay, I subtracted the 4. You had negative 2y equals x minus 4. That's good. When you divide by the negative. Okay, let's go with it. So we got a negative 1/2 x. And now we can check if we did f of f inverse, we should get x. And if we do f inverse of f, we should get x. But I'm just going to submit this just for the sake of time. Negative 1/2 x plus 2. Off. Settings, on screen keyboard is off. So we got a -1/2. Nope, that's not a negative. -1/2 x plus 2. I feel like it should be a positive slope though. Let's go with it. Okay. Then graph the function in its inverse. So I'm going to click to enlarge. So these are both lines. First point, we're going to have to move these points. Okay. So our y-intercept is 4. Can I just type to edit? No. Line tool. I'm going to have to, okay, we got that one. So if the y-intercept is 4, and then the slope is -2. So if we go down 2/1, we can get this point here. What point is that? I want that to be 2, 0, right? When y is 0, let me see, when x is 2, y is 0, right? Okay. So then I guess we need to plot the other one as well. Let me see. -1/2 plus 2. So now I'm just dragging the points. All right. I'm gonna close this. I noticed it. Oh shoot, I think I lost all my work. I gotta do it again. All right. So the y-intercept was 4. I'm just plotting the 2 points and then I'm dragging them to where they need to be. I think those are those two. And then the other one, y-intercept was 2. Let me see, we need another point. Let me hit save. I know that's not right, but. So when x is 0, y is at 2. When y is at 0, I think, let's see, -2, multiply both sides by -2 is +4. So x is at 4, 4, 0. Let's see if that works. Yeah, so when x is 4, y is 0, okay? So I wanna edit when x is 4, right here. I think that's right. Okay. How do I save it? Let's right click here. Four zero. Shoot, we had it. 4, 0 and 2, 0. I think those are correct. Let me hit save. We're gonna cross our fingers because we gotta get going. Okay. The function is 1-to-1. The domain. What does this say? Give the domain and the intercepts of the function and its inverse. First, consider this. Give the domain. The domain is all reals. So we're gonna go parentheses, -infinity to infinity. Okay, so that's the very left to the very right. I think all of these for this one is going to be, let me see, the x-intercept for that one, that x-intercept was what, 2? When x is 2, y is 0, right? X-intercept is 2. Y-intercept, when x is 0, y is what, 4? Okay. The domain of the inverse is the same, parentheses, -infinity, and +infinity, okay. X-intercept, oh, then it flips, right? Because if we got, I don't know why I didn't think of that before for the other one. Shyster. I think it's 4. So this one is 4, and then the other one is 2, right? So x and y intercepts and domain and range flip for a function and its inverse, okay? Okay, we said 10 minutes. Hey Siri, set a timer for 10 minutes.
10 minutes starting now.
So I'm gonna hop to, first I'm gonna check on you guys in Zoom, and then I wanna hop to the next section. Allow, if we can get this to behave. Submit. Allow. View. Allow. All right, let me allow. Did I click on college algebra 2? I think I clicked on the wrong course. Y'all didn't. Oh no, we're in the right. We're doing, that's fine. We are college algebra 2. See, I'm getting young in my old age. College algebra 2 is correct. Okay, allow. All right, so let's take some time to go through section 2.5. Oh, come on. Of course, this is how it's gonna behave. View. Allow. 2.5, come on. The connection is not lost. I don't know what you mean by that. Yeah, I don't know, he didn't say anything. Let's see. What if I go to manage? Will that work? Allow. All right, let's try just closing this out. Let me sign out. It lets me get here, but then when I try to do this, come on, you know you want to work. There you go. Good girl. Okay. That was an adventure. Okay, let's just start. Let's start with question 1. Find the domain. Okay, so for something like this, right? In general, for a rational function, the domain is all reals except any x that makes the denominator 0. So the solution here is going to be everything except -5, and that's captured by C. Okay, next question. Same thing here. Everything except, so if you say y² plus 8 equals 0, you know, you're going to get y² equals -8. There's no real number that you can square to get a negative. So the domain here, so that means that there isn't, you're not going to find a y to make the denominator 0. So that means every y is accounted for. So the domain is all reals, -∞ to infinity. Okay. There's no y to throw out. Find the domain. Okay, we set the denominator equal to 0, and that's what we have to throw out. It's like it's what, 6 and 4, +6 and -4. So then the zeros end up being -6 and +4. So we have to throw out -6 and +4. All right, I just didn't write it out. All I did was set the denominator to 0 and solve. That basically ends up being factoring, you know, things of that nature. Use the graph of the rational function. Okay, as x approaches 3 from the right, so that plus that plus above the 3, it says as this is saying as x approaches 3 from the right, y approaches what? So as x approaches 3, 1, 2, 3 coming from the right, y goes to negative infinity. Okay. As x approaches -1 from the right, y goes where? So -1 from the right, y is tending to negative infinity. Okay. As x goes to positive infinity, so x goes off to the far right, y tends to, it looks like it's tending to 0. Okay. What's the time? Okay. I think I'm actually going to hop to the next section. What are the vertical asymptotes? Let me see. It looks like it's x equals, type in equation, x equals -5 and 5. So then we're going to say x equals -5. Maybe I can just do -5 and 5 like that. Type in equation, use commas. Okay. Let me see. Yeah, I think it might be the way we wrote it. Let's put x equals like that. Okay. All right. Hey Siri, change. Hey Siri, change the timer to 10 minutes. Oh. Hey Siri, set a timer for 10 minutes.
10 minutes, starting now.
I guess we could have used the regular alarm. Ugh. It keeps like closing my windows. I don't want to manage. I want to view. Allow. All right. So let's take some time to go through section 3.1 exponential functions. Let's improve the score. Continue. Let's work on question 10. Let me see. Use transformations of the graph f of x equal to e to x to graph the function below. Okay. So we have two transformations. The base function is e to the x. We have a -6 inside our base function and a -3 on the outside, right? So the -6 should move it to the right 6 and down 3. So we're going to start with the exponential function. I'm just clicking anywhere on the graph. We have the base is e. We're going to the right by 6. So I'm gonna hit a 6 here, and we want to go down by 3. So I want to change this to -3. That's it. I want to hit save and check. Okay. What equation represents the asymptote? Okay, so normally it's y equals 0, but because we went down by 3, it's going to be y equals -3. What's the domain? For exponential, in general, the domain is all reals, the very left to the very right. So it's going to be the same here. Okay. The range is the very bottom to the very top. Normally for an exponential function, the range goes from 0 to infinity, but the open interval from 0 to infinity, but because we moved it down by 3, it's going from -3 to infinity. Okay, write an equation of the graph in its final position. We started with 7 to the power of x. It says 4 units to the left, so that means we need to add 4 on the inside, and then 9 units up. So then add 9 on the outside. So I think it's A. All right, let's go with the A. We got time for maybe 1 or 2 more. Using the formula for simple interest, find I. Okay, simple interest formula is I equals PRT, so the principal times the rate times the time. 6 months, the time has to be in years, so it's going to be half a year. Percent has to be in a decimal, so that's going to be 0.09. Hey Siri, what's 1452 times 0.09 times 0.5?
52 times 0.09.
Ah. Hey Siri, stop the timer.
It's canceled.
I knew there was a timer going. Hey Siri, what's 1452 times 0.09 times 0.5?
1,452 times 0.09 times 0.5 is 65.34.
Okay. Let's do one more and then we'll call it a day. If 5,000 is deposited into a bank account paying 4% compounded quarterly, what amount would be in the account after 7 years? How much interest, right? So this is the compound interest formula. I'm gonna take some notes here, right? So the future amount is gonna be equal to P times 1 plus R over N to the power of NT. Now that's compound interest formula, right? So we're starting, we're solving for the future amount, so I'm gonna just get rid of that. We're starting with $5,000, so P is 5,000. If it's paying 4%, that's going to be 0.04 as a decimal. Compounded quarterly, so that means our N is 4. Same guy here. This one is also 4. And then 7 years. 7 years, right? So that's the number that we need to crunch. I'm gonna try with Siri. $1.01. Hey Siri, what's 5,000 times open parentheses 1 plus 0.04 divided by 4 close parentheses to the power of 28?
5,000 times 1 plus 0.04 divided by 4 to the 28th power is approximately 6,606.4548.
I think that's what she said. Hey Siri, repeat that answer.
5,000 times 1 plus 0.04 divided by 4 to the 28th power is approximately 6,606.4548.
6,606, like this? Hey Siri, repeat that answer.
5,000 times 1 plus 0.04 divided by 4 to the 28th power is approximately 6,606.4548.
Okay. So then it says round to the nearest cent. The nearest cent, we got to look at the 5. To the right of the 5 is a 4. So that tells us to say the same. So we're going to leave it as 4,5. I think that's the right number. That's about the best I can do. I was just trying to be sure before I got rid of all that work. $6,000. Wow, it took almost 7 years for it to double. Okay. All right. All right, gentlemen, if there aren't any burning questions, we are going to end the session here. And from one beautiful mind to another, guys, enjoy the rest of your day. Okay, take care. Peace.